Richard Nye the Math Guy. Richard Nye the Math Guy. Tick, 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 tick. Richard Nye the Math Guy. Alright everyone, for today, tomorrow, and possibly a while after that, we're going to be talking about introducing functions. This includes domain and range of functions, compositions of functions, inverse functions, and domain and range of compositions and inverse of functions. Today we're going to be looking at the domain of functions. Domain is all possible x values a function can have. However, radical rational functions have domain restrictions. Shut up, old lady! Anyway, let's start with a radical function. As you can see, it goes right at a point and does not have any x values to the left of that point. To find the domain algebraically, we must originate it to its parent function, y equals the square root of x. Now for every number added to the parentheses, the function is moved in the opposite direction, such as y equals the square root of the quantity x minus 1, being moved to the left 1. The domain has become x is greater than or equal to negative 1. For rational functions, the domain restrictions are the solutions to the numbers on the top. An example would be x plus 1 over x minus 9 squared. This would mean that the domain restriction is x plus 2, and the domain is all reals except... Oh my god!
Right, sorry about that. The people responsible for casting that nut job have been sacked. So anyway, for a function, the range is the set of y values that a function is not undefined in. Range limitations change because a function has been moved up or down. As you can see here, the function's y values are limited. They will never be less than 0. Next up, we have inverse functions. An inverse function is the mirror image of a function. The function has been flipped over the origin, or the line y equals x. To find out if two functions are inverses, put one function into the other as x, and then solve. If both functions end up with x, then the functions are inverses of each other. Also, for a function to have an inverse, it must be 1 to 1. This means that a function must not repeat a y value. Since an inverse function is still a function, one would find domain and range just like a regular function. The way you would find whether or not a pair of functions are inverses is called a composition of function. This is written as f of g of x, or f parentheses g parentheses x. To find the domain for a composition, find the domain of the inner function and, if applicable, apply the domain restrictions of the outer function to it. To sum up, domain is all possible x values and range is all possible y values for a function. Inverses are mirror images of a function across the line y equals x, and they're also 1 to 1. To find, solve each function into the other for x. Compositions of functions are two functions applied to x.
Where am I? Hey look, an example. This is a graphic example of an inverse function. You get that? Here's the algebraic form. Now for compositions of functions. This is the graphic form. Now, here's the algebraic form.
Hi, I'm the editor of this fine video, so I didn't do anything. Here are some bloopers.
I need a Sharpie.
Don't hit on the brakes.
Now for the...